Okay, let's just dive right into this. Welcome to The Explainer. So, I've been guiding developers and teams through complex architectures for over 15 years now, and today we are tackling a seriously foundational piece of any robust software architecture. We're mastering automated database migrations. If you've ever felt that pit in your stomach anxiety right before deploying database changes, well, you are in exactly the right place.
Hey, did anyone run the alter table script on Prad? The app is crashing. Oof. We have all been there, right? You ship a brand new feature, the code compiles beautifully, your CI/CD build passes with flying colors, and the deployment goes out. You're feeling great. And then that dreaded Slack message pops up. The application is crash looping. Why? Because someone somewhere along the line just forgot to manually execute a database script.
Section 1. The problem. Did you run the SQL?
You see, the root of our crashing app isn't bad developers. It's bad processes. When we rely on human memory to execute SQL scripts, things are just going to break. No one actually remembers what ran where. Your development environment ends up with a completely different schema than staging. And staging? Well, it's totally out of sync with production. For a lot of teams, this kind of manual chaos is literally the norm. Their only documentation is like a shared Google Doc filled with raw SQL snippets and maybe a vague note that says, run this sometime in Q3. All it takes is one missed script to bring down production. But here is the paradigm shift, the Flyway approach. We are going to start treating your database schema exactly like you treat your application code. We're talking versioned, strictly ordered, and entirely automated.
Section 2. Schema as code. Introducing Flyway. So if you're working with modern stacks, say Spring Boot 3 with H2, Flyway integrates so seamlessly it basically becomes the version control system for your database. Instead of logging into a database client and manually executing your commands one by one, you just drop your versioned SQL files into a specific folder right in your project. When your application starts up, Flyway automatically scans that folder and safely handles the entire migration lifecycle before your app even begins accepting traffic. It's a real game changer. But to make this magic actually happen, Flyway relies on a very strict naming convention. It always starts with a capital V followed by a version number. Then, and actually underline this in your mind because it's absolutely crucial, 2 underscores, not 1, 2, followed by a description and ending with .sql. So, for example, v1 __ create users table.sql or v2 __ add email to users.sql. This specific file naming is the secret sauce that allows Flyway to scan your project, sort your schema changes, and guarantee they execute in the exact correct order. Section 3. The Flyway brain. The Flyway _ schema history table.
Now, you might be wondering, how does Flyway actually know what has already been run in your database and what hasn't? Well, it creates and maintains a special table inside your database called Flyway _ schema history. Think of this as Flyway's brain. This table is its ultimate source of truth. Every single time a migration runs successfully, Flyway inserts a row right here. It logs the version number, the description, a unique checksum fingerprint of the file, which is super important, and the exact timestamp of when it was applied.
Section 4. The startup flowchart, step-by-step execution. Because it has that history table, Flyway can perform this highly orchestrated dance every single time you boot your app. The moment your application starts, here's exactly what happens behind the scenes. Step 1. Flyway checks if the Flyway _ schema history table exists, and if not, it just creates it. Step 2. It scans your db/migration folder for those .sql files we just talked about. Step 3. It compares the files it found against what is already logged in its history table. Step 4. It brilliantly skips anything that has already been applied. Step 5. It takes any pending files and runs them in strict sequential order. And finally, Step 6, it records the result of each successful run back into the history table. It is elegant, it's predictable, and it is totally automated.
Section 5. The Command Toolkit. Essential Flyway Operations.
As an engineer, you really need to understand the levers you can pull here. There are 6 core commands you must master. First up is migrate. This is your workhorse. It applies all pending migrations. Next is clean. Now, please listen to me very carefully on this one. Clean drops absolutely all objects within your schema. It's fantastic for wiping a local development or maybe a testing environment, but you must never, ever run this command in a production environment. Seriously, just don't do it. Then we have info, which prints a really nice comprehensive status report showing you what's pending, applied, or failed. Validate is your integrity checker. It ensures your applied migration checksums match the files currently sitting on your disk. Baseline is incredibly useful if you're onboarding Flyway onto an existing database that already has live data. It basically tells Flyway, hey, mark the schema as already being at version 1. Don't run the initial creation scripts. And finally, repair. If a migration fails or your history table somehow gets out of sync, repair helps fix the history table by removing failed entries and realigning those checksums.
Section 6. Checksums and fix forward. Production grade safety.
Understanding those commands is great, but let's elevate this to true production-grade safety. The absolutely crucial point here is checksum protection. Flyway operates on the strict principle that once a migration is applied, it is immutable. It cannot be changed. Remember that checksum fingerprint we mentioned in the history table? On startup, Flyway actually recalculates the checksum of your local SQL files and compares them to what's in the history table. If a developer goes back and tries to quietly edit v1 create users table after it's already been applied to production, the checksums are going to mismatch. Flyway will immediately throw a validation error and your application will flat out refuse to start. This is exactly how you prevent silent database corruption. Now, this immutability leads us to a fundamental rule of database management. We all share that collective trauma of frantically writing a manual rollback script at 3 a.m. because something broke, right? But a terrible practice is trying to manually delete or edit a script you already ran. Because of those checksums, that will just cause a validation failure. The correct practice, and frankly the only acceptable rollback strategy in a professional pipeline, is the fix-forward rule. If you made a mistake in version 8, you do not touch version 8. Actually, scratch that. You pretend version 8 is locked in a vault. Instead, you create a brand new file, version 9, written specifically to safely reverse or fix the changes introduced in version 8. This is what guarantees an unbroken, accurate audit trail for your team.
By treating your database schema as code, utilizing the history table, and adhering to strict immutability, you completely transform a messy, stressful manual process into a fully automated, audit-trailed, and team-safe pipeline. So the next time you prepare for a big deployment, ask yourself, are we still relying on human memory, or are we ready to let Flyway do the heavy lifting? Don't forget to check the description for the full article and code snippets. If you enjoy this video, please give it a thumbs up and subscribe. It really helps the channel. Let me know in the comments what topic you want to see next.